In this video, we're going to look at another type of addition reaction. This time we'll be looking at hydrohalogenation. We're going to start by investigating what hydrohalogenation is, so we're going to break down this name. So hydro is from hydrogen, and halogenation, so halogen, that's exactly what it sounds like, a halogen. And so we're going to add a hydrogen and a halogen across a double bond in an alkene. So I'm going to give a brief schematic of this using X as my halogen. So if we had ethene, so our simplest alkene, and we added, I'm going to do this in a different color, HX, where X is going to be a halogen. So halogen will be fluorine, chlorine, bromine, or iodine. Double bonds are very reactive, so we don't need any sort of catalyst here. And so what's going to happen is that HX is going to split apart, and one will go on one part of our double bond, and the other will go on the other. So our hydrogen will go onto one carbon, and our halogen will go on to the other. And our product is an alkyl halide. And in these reactions, you can break or you can get rid of one double bond for every mole of HX you add. We're going to look first at the example of adding hydrogen bromide to but2-ene. So I'm going to draw but2-ene here. And for this first one, I'm going to draw it as our structural diagram so that we have full detail as to what's happening. So but2-ene is going to have a double bond on our second carbon between carbons 2 and 3 within our 4-carbon chain. And the carbons with the double bond will only have one hydrogen each. We're going to add to but2-ene hydrogen bromide. So I'm going to write this in a different color so we can track our hydrogen and our bromide. So when we do this reaction, our hydrogen is going to go onto one carbon of our double bond, and our bromine is going to go onto the other. Now in this case, it doesn't matter which one we put where. In some examples, it will. So we have our but2-ene, but now we don't have any double bonds, so I'm going to just draw a single bonded chain of 4 carbons, and I'll put on all of my original hydrogens. At carbons 2 and 3, I will have added a hydrogen and a bromine. So I started with but2-ene, and I have formed 2-bromo-butane. Our next example, we're going to look at the addition of hydrogen chloride to propene. So I'm going to draw propene this time as a line structural diagram. And the reason we don't put a number in propene is that regardless of where the double bond is, it will always be between carbons 1 and 2. So we have propene, and we're going to add hydrogen chloride, HCl. So I'm going to highlight the 2 carbons that are involved in my double bond. So I have my red carbon on the end, and I have my green carbon in the middle. And I'm going to just look at where we place that chlorine. So this is an example where we're going to have 2 products. So if I place the chlorine on my red carbon, I get rid of that double bond, and I'll have a little chlorine stuck to carbon 1. Now you don't have to draw this, but the hydrogen will be on carbon 2, so on either side of that double bond. If instead I stick my chlorine where that green carbon is, all of a sudden my hydrogen is on carbon 1, and my chlorine is on carbon 2. So in the first case, I'm going to get 1-chloropropane, and in the second, I will get 2-chloropropane. So the products are isomers, but they are different. We'll get into this more in a later video, but just note that it is possible to form different products with addition reaction.